Hello guys, today we are starting the basic concepts of probability along with statistics. Okay, first write name. Okay, in these two topics, first we are starting the probability and then we are going to move on to the statistics. Now write a heading probability. Okay, in this we are firstly discuss about the random experiments. Side heading is random experiment. Okay, first we have to know what is the definition of random experiment and what is the meaning of random experiment. First we want to write and then I will explain that. If an experiment is conducted any number of times under essential and identical conditions, there is a set of all possible outcomes associated with it. This experiment is called a random experiment. And the outcomes are called elementary events. Okay, this is the definition of random experiment. Now we want to discuss about what is the random experiment in detail. Suppose if an experiment is conducted any number of times, suppose maybe 2 times, 3 times, any number of times, then under essential and identical conditions, there is a set of all possible outcomes associated with it. Means a set of all possible outcomes are associated with that experiment, then the experiment is called random experiment. Okay, and the outcomes are called elementary events. So this is the random experiment definition, and we are moving next to heading that is sample space. Sample space. Okay, next first we want to discuss what is the exact definition of the sample space. The set of all possible outcomes in a trial is called sample space. So first we want to write the definition. The set of all possible outcomes in a trial is called sample space, and then the sample space is denoted by letter capital S, and the subset of sample space in an event is denoted by E, and the subset of a sample space is called an event is denoted by letter E. Next, for better understanding this sample space, we want to draw a sample space. What is the sample space we want to draw? This is a sample space. sample space, yes, it is denoted by letter S, and the set of all possible outcomes in a trial is called sample space. So assume that the sample space consists of two trials, that is, sorry, one trial, but it outcomes is two, possible outcomes is two, that is A and B, and these are A and B. This the portion of joining which are intersecting the A B is known as E. It is a subset of A and B. So in this sample, A and B are the possible outcomes, and the E is the subset of A and B in this sample. So this is the sample space, and for example, for the sample space is examples is first we take an example, tossing a coin. Example is tossing a coin is a trial and getting the outcomes, that is only two outcomes in a coin, that is one is head and another one is tail. These two, head and tail, is called events. A and B are the two events. We are taking the A and B, and here we are taking head and tail. Head is A, tail is B, and the sample shape is denoted by letter S is equal to set of head and tail. This letter S is consist of head and tail, and this means in a sample space S, the head and tail are the two possible events, two possible outcome events. This is the definition of the sample space, and next we are going to equally likely events. Next, equally likely events. First, we want to know what is the definition of equally likely events. First, I can write the definition. Events are said to be when there is no reason to accept any one of them rather than any one of the others. It means this is the definition of equally likely events. What is the definition says? In an events are said to be when there is no reason. It means there is no reason to accept any one of the event. That is, in a sample space, in an event, it's said to be there is no reason to accept any one of them rather than any one of the others. It means for better understanding, we write an example. If we toss a coin, we get the events has head and tail. It means there are two events. There are two events are said to be when there is no reason. There is no reason to accept anyone, either head or tail, with one of them. It means there is no reason to accept either head or tail. This is called an definition. This is said by the example definition of the equally likely events. Next, the example is the probability of these two events equally likely events means these two events are equally likely events, so there is no reason to accept any one of them. That is equal to, it can be indicated by mathematically or theoretically, p of h is equals to 1 by 2. It means in a, to getting the head in a, these two tiles and two events, one is head, one is tail, so we can divide it into total number of set into the events, number of events, total number of tiles conducted in the experiment by number of events we getting, possible events, that is head and tail. So total number of experiment conducting times is 1, so we getting two events, that is head and tail. So we are getting, to getting the probability of head, we are writing the 1 by 2, and the probability of t we are getting is 1 by 2. So p of h and p of t, p of h plus p of t is equal to 1 by 2 plus 1 by 2 is equal to 1. So the total number of experiments in the sample space is 1. So this is the equally likely events. Next we are going to the another topic. Next we are discussing the exhaustive events. That is exhaustive events. That is, first what is that? I can write the definition. All possible events in any trial are known as exhaustive events. That is, all possible events in a trial are known as exhaustive events. Suppose, take a sample space. Yes. In this, assume that there is a number of events like A, B, C, D, and E, etc. The all possible events in a trial. In this sample space, assume that this is a trial. In this, the all possible events in a trial is known as exhaustive events, because these are within the exhaustive in this trial. So we are calling as exhaustive events. Now, for example, in tossing a coin, we have two exhaustive events. They are head and tail. Suppose if you can toss a coin, then that in the trial we have only getting two events, one is head and one is tail. So these two are the exhaustive events of that trial. If conducting if we can taking another example, that is throwing a die, the all exhaustive events in the trial is number of events is 6. That is 1 to getting 1, 2, 3, 4, 5, 6, 7, 6 until 6, 1 to 6. These are 6 are the exhaustive events in that trial, and this tossing a coin, the exhaustive events are 2. That is, one is head and one is tail. And then next, mutually exhaustive event. We are completed the exclusive likely events and exhaustive event. Now we are going to the mutually exhaustive events. Okay. Now, first we have to write the definition of mutually exhaustive events. What is the exact definition of the mutually exact event? Is events are said to be mutually exclusive if the happening of the other of any one of the events prevents the happening of the other events in a trial. . That is, another definition is, or another way we can say that no two or more of the events can happen simultaneously in the same time. So from the definition, it is said that no two or more events can happen simultaneously in the same time. That is, no two or more events can happen simultaneously in the same time. Suppose in tossing a coin, we are getting one head and another. We are getting tossing two coins at simultaneously in the same try, or two times a single coin tossing. We cannot getting two times head or two times tail at the same time. These are called as these are explained by the mutually exhaustive events. This can be briefly discussed on the problems. Next, we are going to the next topic, next definition. That is classical definition of probability. Classical definition of probability. Let E be an event of an experiment. Let E be an event of the experiment. There are n mutually exhaustive events or exclusive events and equally likely events and this is known as equally likely. Elementary events also is equally likely events. They both are same. And m elementary events are favorable to E. That is, P is equals to P of E, that is equals to m by n, that is equals to number of favorable conditions or cases divided by total number of exhaustive events, or exhaustive cases also can be written. That is, classical definition of probability means P is equal to means probability of an event is equal to m by n. This is the most important formula in the next going. This formula we will use in next problems, and this formula is m by n. M is number of favorable cases, and then n is total number of exhaustive cases. And there is another formula like this. That is, we are P is equal to we are going to P of E is equals to m by n. If P inverse there is a positive value of E and the negative value of E, that is P E dash, we can write as an P E dash is equals to 1 minus P of E, that is equals to 1 minus m by n. Okay. In this case, P will not happen. in before this case, P in this P of E case, P will happen. In this P of E dash case, P will not happen an event. An event is not happening, then the formula is this. If the P event P of E is will happen at the event, so the formula is only m by n. Okay, next, that is, this can be written as also simplified. P plus Q is equals to 1. That means where P is equals to P of E and Q is equals to P of E dash. Whereas we can simplify this. P is positive, Q is negative. So if negative, there is a negative. So here we have additional number. So we have additionally before 1. This is a shortcut. This is not in the syllabus. Okay, next we are going to the another. And there is a note here. Note, always 0 less than or equals to P less than or equals to 1. That is, P is lies in between 0 to 1. And similarly, 0 less than or equals to Q less than or equals to 1. That is also similarly as P and Q are both are in between 0 and 1. Not exceed the 1 and not exceed the 0. So there is no negative values. Only there is a less than or equal to 1. And in between 0 to 1, P and Q both are the in between 0 and 1. Next topic is axials of probability. Axials of probability. Now we have 3 main formulas in this axials of probability. Step one by one we can write in the paper. First one, P of E. It is P happen at events is greater than or equals to 0. In this case, for all E is less than or equals to S. That is, E is a smaller value because S is a sample space, it is a larger value, and E is one of the portion in the sample space. So E is always less than S. And second one, P of S is equals to 0, where S is a sample space. First one is P of E is always greater than or equal to 0 for all E less than or equals to S. And second one, P of S is equals to 0, where S is equal to sample space. And third one, if E1, E2 and E3 and so on until En are n disjoint events, then P of E union, E2 union, E3 union and so on union En is equals to P of E1 plus P of E2 plus and so on P of plus P of En. That is, if E1, E2, E3 and so on are the n distinct joint events, then P of E1 union, E2 union, E3 union and so on union En is equals to P of E1 plus P of E2 plus and so on P of En. This is the formula. These 3 formulas are the most important in the next going to the problems, for the next doing the problems. And next we are going to move on to the addition theorem. This is the most important theorem in the examination. Addition theorem. This is the most important in the examination point of view, so we can mark it with the red pen. Okay. Now, first, what is the write down the statement? Or there is no longer statement, and there is only one definition. If A, B are any 2 events, then P of A union B is equals to P of A plus P of B. As we know that from above the formulas, 3 formulas, as same as from this formula, this is P of E1 union E2. That is, we are taking that instead of E1 and E2, we are taking A and B, A union B is equals to P of A plus P of B. For n number of distinct events, we can increase this number. If there is any number, n number of events, here also we can divide it and added this sum of events. Okay. Next, and then and final, this not is completed. This formula is not completed. P of A intersection B. This is the most important. There is P of A intersection B. This will explain after how it comes. Okay. Next, there is a similar formulas like this. That is, this is known as addition theorem. Just a second. Okay. Much better right now. Note. In this note, there is a similar formulas like this. If P of A union B is given, then the formula is this. If P of A intersection, A dash intersection B, if the formula is given like this, then P of B minus P of A intersection B, that is, whatever the dash is, there is a dash in A, so it cannot comes in here. Only the probability of B will calculate, and the, this total is the P of A dash intersection B. And similarly, there is another formula. If P of A intersection B dash, then the formula is P of A minus P of A intersection B dash. Sorry, only B. Here also only A. That is, for the removing of A dash or A intersection, or sorry, A dash or B dash, we can write that as like this. If the problem is not is given, the formula is directly given like this, A union B, so we can directly substitute this formula. Otherwise, if the dashes are given, A dash, B dash, C dash like this, we can use this formula. Again, we get the values, then it will substitute on this. Okay, next we are moving to the another formula. There is a third formula, that is P of A union B union C. SM, this is for 2 events and this is for 3 events. This is equals to P of A plus P of B plus P of C plus, sorry, minus this is P of A intersection B minus P of B intersection C minus. Okay, then the third formula is P of A union B union C, that is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C, C intersection A, and finally the plus P of A intersection B intersection C. Here is plus, these 3 are minus, and first 2 are plus. Totally 3 pluses and 3 minuses. So this is the addition theorem. Next we are going to the another definition, that is, sorry, another topic, that is de Moivre's theorem. Next, de Moivre's theorem or de Moivre's theorem. Now, first we want to know what is the we don't want the definition, that is confusing. So, first, what is the exact formula of? First, there is 2 formulas in de Moivre's theorem. A union B, whole dash is equal to A dash intersection B dash. That is, what's de Moivre's theorem explain that the whole dash of A union and B union is equals to A dash intersection B dash. And there is another formula, that is second one, A intersection B whole dash is equals to A dash union B dash. Similarly, as same for the, if we are in this in this, if we have union, here we have intersection. If we have in here intersection, then we will get union. First, if you have intersection, then we will get union. Similarly, as both same, but if we have union, then we get intersection, or if we have intersection, we get union. This is explained by the De Moivre's theorem, and this can be used in further formulas, further problems. These formulas are used in many ways, many times. And next, another conditional events. Conditional events. Now, first we want to write the definition. If E1, E2 are the two events, or any two events, okay, what De Moivre's theorem said that, okay, we are completed the De Moivre's theorem, sorry, we are on conditional events. First, the definition of the conditional events is, if E1, E2 are any two events of a sample space yes, and if E2 occurs after the occurrences of E1. Here the E1 event E1 is called conditional events. Of E2. It is denoted by E2 by E1. Next, conditional probability. Next, the definition is conditional probability. First, we want to write the definition of the conditional probability. The probability after the event E1 has occurred is called the conditional probability of the event E2. That is, the probability of E2 after the event E1 has occurred is called conditional probability of the event E2. Then and given data, given event in the data, if it is denoted by P of E2 by E1. Okay, that is, conditional probability is denoted by P of E2 by E1. Now, what is the formula for the extension for the P of E2 by E1? you want to write that P of E2 by P of E2 by E1 is equals to P of E2 intersecting E1 by P of E1, or it is also can be written as, instead of E2 by E1 we can use an AB, P of B by A is equals to P of A intersection B by P of B. Or instead of, if there is another way, that is P of A by B is given, if P by, instead of B by A, if A by B is given, it is simple P of A intersection B, as same both for on top and bottom. Here the A is given on, sorry, here A, if here A is given on the downside, so we can write here is A is on downside, so here B is given on down, so on downside we can write that P of B. Both are same, but the difference is, if A is on downside, then we can write as P of A. If B is on downside, then we can write that P of B on downside. This is the formulas, and we can where E2 is the bigger value or E1 is smaller value, either it will given on the problems. Okay, next we are moving to the another one, that is, next we are going to the another theorem, that is multiplication theorem. Multiplication theorem. Of probability. Okay. Now, what is the multiplication theorem of probability? First, I can write the definition. If A comma B are the any two events, then by the definition of conditional probability, it can be written as P of A by B is equals to P of A intersecting B by P of B, where P of A intersecting B is equals to P of A into P of B. This P of A intersecting B is equal to P of A into P of B is known as multiplication theorem of probability. First, before this we are discussing the addition theorem of probability. Now it is a multiplication theorem of probability. Here we can substitute this in formulas and replace this, and we can continue in, we can do it in further formulas, further problems. So we are moving to the there is an for the similar to that, we have written the A by B, it is similar to B by A also. P of B by A is equals to P of B intersection A or A intersection B. Anyone is in right, or both are same. A intersection B and B intersection are same, and it is here P of B intersection A is equals to P of B into P of A. Both are same, we have getting the same answer, so don't worry, no worry about this changes A and B. Okay, next we are moving to the another one, that is Next, the next topic is independent events. This independence and then next there is dependent events. These two are the most important definitions in the examination section. So first we want to write the definition of what is the exact definition of independent events. If P of A by B is equals to P of A and P of B by A is equals to P of B, then A and B are called independent events. Independent events. If P of A by B is equal to P of A and P of B by B is equal to P of B, then A, B are called independent events. Okay. Next, if A comma B comma C are any events in a sample space, then P of A intersection B is equals to P of A into P of B, then P of B intersection C is equals to P of B into P of C and P of C intersection A is equal to P of C into P of A. If P of E1 comma E2 comma E3 not equal to 0, next, this is the definition and theory part about regarding to the probabilities and distribution functions. Now we are entering into the problems. Now first take an example problem, that is problem number 1. What is the probability that question number 1, a leap year consists of 53 Sundays. And then second one, a non-leap year consists of 53 Sundays. These are the two problems are given in the okay. First we are solving the first problems. First one, solution. Condition number 1, a leap year consists of 53 Sundays. It means what is the probability of a leap year consists of 53 Sundays? The question is this is the question, and to find out that a leap year consists of a leap year means number of days in a year is 366. So a leap year consists of 366 days per year. Next, for Sunday it is a weekly once, so we can multiply this value, we can divide this value into 7, that is 7 days in a week, that is 366 divided by 7. So we are getting 366 divided by 7, we are getting that 52.28, that is 52 means 52 weeks. We can simplify this as into days and weeks. So 52 weeks and 2 days plus 2 days. So until we have taken the days, so we can stop here until the days. So because why we are taking these days, after the smaller value of v we have the days only, so we can take the after the point we have days. If then next it is an there is a value of 8, it is taken as hours. So 52 weeks 22 days 8 hours or something like this. So we can say this, in 52 weeks we have 52 Sundays, that is in 52 weeks we have 52 Sundays, and in remaining 2 days there is one is Sunday and another one is either Monday or Saturday, that is either Sunday plus Monday. There is a cases or Monday in these 2 days plus Tuesday, or Tuesday plus Wednesday, or Wednesday plus Thursday, or Thursday plus Friday, or Friday plus Saturday, or Saturday plus Sunday. Only these cases, these 7 cases we are getting at these 2 days. Either in these 2 days one day is Sunday or Monday, or Monday or Tuesday, or Tuesday or Wednesday, or something like this, or Saturday or Sunday. There is, to getting 53 Sundays, there is only 2 cases. One is Sunday Monday or Saturday Sunday. In these 2 weeks or 2 days only we have Sundays and Sundays. So next this is can be written as this can be written as let E is equal to a leap year consists of 53 Sundays. So P is equals to P of E is equals to M by N, where M is an number of events on the trial and the total number of mutual events. We are discussing on the before that is number of favorable cases, where m is a number of favorable cases, number of favorable cases by total number of exhaustive cases. Here the number of favorable cases is only two. One is Sunday and Monday, and the next one is Saturday and Sunday. So only two by total number of exhaustive cases. Total is 7. Within 7 we have only two favorable cases, as said before. That is, if we calculated this, we get 2 by 7 is equals to 0.2857. That is, first we are discussing about the first at the starting. We know that probability is within 0 less than or equals to p less than or equals to 1. We know this condition. This condition is satisfied this, so this is answer is correct. That is, the probability is within 0 to 1. It is 0.2857. There is a chance, it means to getting a 53 Sundays, in a leap year, we have 0.28%. That is 28%. 28% of chances. And next, in second case, a non-leap year consists of 53 Sundays. As we know that we are calculated that a leap year consists of 53 Sundays is 28% of chance per year, and then a non-leap year consists of 53 Sundays. That is, we know that the number of days in a non-leap year is 365 days. 1 year is equal to 365 days. That is 365 divided by 7. Then we get 365 divided by 7. We get that answer as 52.1. That is 52 weeks and plus 1 day. In this 1 day means 1 day is either it's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. There is 7 number of exhaustive cases in this 1 day. That means 1 week. There is 7 days. In this only 1 day is, and we want only Sunday. So there is only 1 day, that is Sunday. So number of favorable cases is 1. So P is equals to P of E is equals to M by N, same formula, that is equals to number of favorable cases is equal to 1, and total number of exhaustive 1, 2, 3, 4, total 7 days in a week. So 7, that is equals to 1 divided by 7 is equals to 0.14. That is 14% chances. to getting the 53 Sundays in a non-leap year, and 53 Sundays to getting the leap year is 0.28%, and to getting the non-leap year 0.14%. And this is also to verify this answer is correct or not, we have condition p is less than in between less than or equal to or greater than equal to, or in between 0 less than or equal to p less than or equal to 1, that is p in between 0 to 1. So this condition is verified, so the answer is correct. And we are moving to the next problem, that is second problem. What is second problem? Next second problem is, what is the probability of picking of an ace and a king from a pack of 52 cards? That is, we want to find out the probability of picking an ace or king from a pack of 52 cards. That is, a card pack consists of 52 cards. Total number of cards is equal to 52. That is a solution. Given A is equals to ace, assume ace is equal to A and king is equals to B, and then A is denoted the event of an ace and B is denoted the event of king. Okay, next, from the pack of 52 cards, there are, for each pack consists of 4 aces and 4 kings, so, and 4 queens, 4 jockeys and jokers and etc. The remaining are the consist of, in every pack consists of this stuff. And next, a king can be drawn in 4 ways and ace can be drawn in 4 ways. From the 4 kings, a king can be drawn in 4 ways and ace can be drawn in 4 ways. That is, now first, for the drawing of ace, that is, total number of favorable cases is 52. Sorry, number of favorable cases is 52. Total number of exhaustive cases is total number of exhaustive cases is 52. Number of favorable cases is 4. Number of favorable cases is 4. So P is equals to P of A is equals to, or we can write also P of E1 also is the correct, that is equals to 4C1. That is, instead of there is 4 cards, instead of 4 we are picking only 1. 4 in 4 ace we are picking only 1 ace, and 52 C1, that is, in total 52 cards we are picking only 1 card. That is favorable cases. In 4 favorable cases, in 4 that we are taking only 1, so we are taking only 1, and then we are from 52 we are taking only 1. This is the condition of formula. This 4C1, we know that 4C1 is equals to 4 and 52C1 is equal to 52. That is equals to, this is also known as m by n, that is equals to 4 by 52 is the condition. To find out the value of 4 by 52, 4 divided by 52, then we get 0.1 by 13, that is equals to 0.0769. These are the condition of, these are the probability to picking the 4 from the 52 cards. We are picking the 1 ace, and for to picking the 1 king from the 52 card, there is a 4 probability favorable cases, that is as similarly as Sam, instead of P of E1 or P of A, we can write as P of B, and 4C1, 52C1 is both are same, that answer also is equal to answer also, final answer also same. Then that is to getting from the 52 cards, after the picking of these two, you can write on next, you can write on here, that is P of B is equals to 4C1 by 52C1, that is equals to 1 by 13, or 4 by 52, both are same. And next, similarly, we have P of A and P of B, and finally P of ace and a king. Probability of getting both ace and king is, it can be determined, can be written as P of A intersection B, because we are taking two cards. So the formula for A intersection B, from the addition theorem, we have P of A into P of B, that is equals to 1 by 13 into 1 by 13, that is equals to 1 by 169, that is equals to 0.005. That is only 0.5% of chance to picking the two cards, or a ace or king of or a king, to picking from the 52 cards.